Okay. So you didn't detect plutonium in Tokyo area?
No, that is to say that it was below the level of detection of the equipment. Yeah.
So you can't say it's zero, but at least it's lower.
You can't say it's zero. But the thing is that the equipment that was used was not used by me. It was, I send this stuff onto other laboratories, and this was the level of detection that they said. And we also looked for strontium-90 in some samples that I got, and I didn't find strontium-90. But again, below a certain threshold. You know.
Well, I was surprised. I think you showed 3,000 becquerels per kilograms of uranium.
Yes,
I think
that's
it was dust on the air conditioner.
We did find uranium, enriched uranium. We did.
Yeah.
This is the sort of uranium we get from reactors. We did find that, and we found that in the Tokyo. The famous sample was the one in that apartment near the Tokyo Tower. That was.
I was happy because I was already in Canada at that time.
Well, the astonishing thing about that sample is that the woman who lived there, she left.
Yeah.
And
so she didn't use
so
the.
It was only just like a short period of time that was running, and it was.
But I wonder, can it happen? I mean, the uranium came from Fukushima to Tokyo, but plutonium didn't come to Tokyo.
No, that's not the point. Plutonium did come, but the amount of plutonium is much smaller. If you take a nuclear reactor, it's mostly uranium. The amount of plutonium in it is very small compared to the amount of uranium. So if you look in the Irish Sea, for example, and you're looking for samples where, because of Sellafield, the reactors, they release all this stuff, you find that when you look at the measurements that are made, plutonium is always quite small. It's very small. It's just it's very, very dangerous, and everybody says, oh, it's so bad, and so on.
So, honestly speaking, which one is more dangerous? I mean, plutonium or uranium?
I think probably uranium is the more dangerous. Yeah, I think so.
But everyone believes plutonium is more toxic.
Yeah, I know. I'll tell you the reason for that. The reason why the uranium is more dangerous is uranium has a very much higher affinity for DNA. So its chemical affinity for DNA is much greater than plutonium. So it's targeting the very piece of your body that is the one that produces the cancer. Okay?
So I mean, the plutonium just sharply kills a cell.
Yeah, it kills
and a cell that
cell.
can't grow up to cancer.
That's right.
It just simply kills.
Yeah. Whereas we know from the work that's been done in the last 10 years with depleted uranium and in the work I've done in Iraq, and also other theoretical work, that uranium has this ability to cause mutations at very, very small levels. And the other thing is that the activity, although the activity of uranium is quite low, the actual mass of uranium is enormously high. So in terms of grams of uranium, rather than becquerels of uranium, there's an awful lot of uranium around. Yeah.
I understand. I think back to vitamin, your idea was to taking calcium before taking strontium prevents your body taking strontium into your body.
Yes, that's right.
Yeah, I think it's the same mechanism as taking iodine.
It is, yeah. That's right.
Before I was refined.
And although I was attacked by a lot of scientists in The Guardian, particularly this woman, Jerry Thomas, who said, oh, he doesn't understand and that there's no affinity of uranium for DNA and all this stuff. Actually, there are lots of studies were done, proper scientific studies were done in the 60s, in which they gave mice calcium tablets, and they showed that that the strontium-90 didn't go into the mouse when it had a high level of calcium. And they did that with people as well. So it was all well known.
So how about iron tablet?
Well, this is interesting. I hadn't thought about that, but you suggested it to me. But iron is involved in the transfer of these big heavy isotopes in the body. It carries them into the cell. There's a transferrin process that carries these molecules into the cell. And that's probably a good idea. But I have to say that it's not quite the same as calcium, because iron is toxic. And if you sort of tell people to take iron tablets and they take too many iron tablets, they're going to get sick.
I can have too much side effects.
Yeah. So you've got to be very careful with iron tablets. You know, they can make you quite ill.
I understand. And have you taken the sample of Tokyo Bay?
No, I would like to very much, because you've been telling me about the way in which the tides work, and one of my major studies have been in the Baltic Sea, which is radioactive, and also in the Irish Sea, which is radioactive, and where you have these tidal differences. And from what you tell me, exactly the same thing is happening in Tokyo Bay.
Yeah, it's a small version of Baltic Sea. Yeah, it's almost close.
So what happens is that the tide comes in, and then it stays there, and then all the particles will come out in the mud, and then the tide will go out and leave the particles behind. So I would very much like to get some samples from Tokyo Bay, from the mud, slimy mud, not the sand, but the slimy mud.
Sediment. Sediment. So
and to see what we've got in there in terms of radiation from Fukushima.
It can be accumulating cesium.
And I can measure that myself. That's not going to be very costly because we can look at the cesium gamma signals. I can do that with my own. Without my own.
You just need samples from Tokyo Bay.
About 1 kilogram.
About 1 kilogram. What kind of sample do you need? Sand or?
No, not sand. No, I want the slimiest sort of mud that you can get. So if you go to the point where there's mud, sort of what we call soft mud. So when you go with your fingers, like it's slippery, like that.
Yeah.
That's the stuff we want.
The perfect one.
Yeah.
Thank you very much.
Okay.